So we're now moving on to lesson 5, and it's talking about potential difference and electrical potentials. Okay, you already know the potential difference is delta V. I think you've learned that in grade 9. Okay, so potential difference is delta V, and electrical potential, we're going to be talking about that today. Okay, so what's the relationship between work and potential difference? Okay, so imagine that if you have a region of space that you have a constant electric field. So I think the easiest thing to imagine is if I have a parallel plate. Okay, between the pair of parallel plate is hooked up to whatever the source is, and it has whatever the potential difference is. And because of this, so I'm just going to say that pretend that I have a positive charge plate on one side and a negative charge plate on the other side. And in the middle, I want you to imagine a positive charge. Okay, so basically this is the same as this picture over here. Okay, the reason why I say that is, think of it. We've talked about that the field is going from positive to negative. So the field, which is the epsilon right here, this is the epsilon. So that this picture still have my epsilon going this way. Like the electric field are definitely going this way. Okay, and then between the left hand side, if I have a positive plate and a positive, do you see that around here I'm going to be repelling, but at the same time the negative is going to want to be attracted to the positive charge in the middle is going to be wanting to be attracted to this side, right? So that's why it's going to be causing some forces and some work that is going to be done by the electric field. Okay, so back to kind of the last unit, work is force times displacement. Okay, and the other equation that you need to remember is the electric force is Q epsilon. So these are old equations that you know. The only thing that we're really changing is the Fe specifically. And what is the electrical potential? Okay, electrical potential energy are basically energy that is stored. Okay, and the equation to find that is delta EE is equals to the negative work. We are going to talk about the positive and the negative work. So they're just trying to rearrange and set up a new equation that is delta EE equals negative Q epsilon times delta D. So change in electrical energy could actually be positive or negative depending on which way you're moving the charge. So remember just now I said I have a positive plate and a negative plate. Okay, same thing with this picture, a positive plate and a negative plate. Okay, basically they're telling you that the delta EE would be a negative number if it's moving with the field. Okay, so do you see how this gray arrow right here, is telling you that the object is moving to the right, and that means as it goes, it's going to be losing the stored energy. And so that's why they say that when you write the equation, delta EE would equals to negative if it's moving with the epsilon, moving with the electric fields, meaning you are losing stored energy. But opposite to that is this. Okay, delta EE, why did I change it to yellow? Delta EE would be a positive value, positive number, if I am actually moving against the field. Think of it, this is positive, right? If I keep bringing the gray arrow is what I'm looking at again. If I am having the gray arrow and I keep moving it closer and closer to the positive plate, do you see how I'm storing more energy? Kind of like in a gravity sense, I'm storing more gravitational potential energy. By moving it towards the positive plate, I'm storing more electrical potential energy. So when I let go, this proton can go and go even further because the acceleration would be greater, causing by the greater work done. Okay, so let's clarify it again. Delta EE would be a positive value if you move against the field. You're storing more energy. So basically, this is now saying that if I'm gaining more store energy. Okay, so change in potential energy is negative when the electric force is working on the charge, indicating less energy is being stored. Okay, and we also do consider the conservation of energy. Okay, next concept, electrical potential. Electrical potential is V. Okay, and basically what it means is it is the amount of stored energy, the value of potential energy per charge. Okay, so the equation is EE over Q. And the unit for a volt from this equation is joules per coulombs. And basically they're saying it doesn't matter how many, you only care about the field strength. Okay, and then potential difference is the change, the amount of energy that it takes for each of the charge to move a positive charge from one point to another. Okay, so if you're changing where you are on the electric field, you will be able to feel the potential difference. Okay, and this is applying to if it's a uniform electric field, meaning a parallel plate. So that means in the question, if it ever mentions a parallel plate, you would be using this equation. Okay, so epsilon, electric field, is delta V over delta D. And it depends if it's a plus and minus, and we will get to that again. Okay, electric field is the largest in the region where V is big. So if you have a big potential, you would have a bigger field. If you have a constant potential, your electric field is 0. So if you actually, like if there's no battery or if there's no plate, you're not going to have an electric field. Okay, question. A proton, it tells you that the charge for the proton is 1.6 times 10 to the negative 19 coulombs, move from rest in a uniform electric field. And part A asks you, calculate change in the electrical potential energy. So what symbol would that be? Okay, so let's just decode it. Calculate the change in electrical potential energy. I am looking for change in electrical potential energy. That's a symbol. And what they gave you is the magnitude of the electric field is 250 Newton per coulombs. So electric field is 250 Newton per coulombs. And the starting position is 2.4 meters from the origin, and the final position is 3.9 from the origin. Okay, so the first place, do you see that they have given you delta G, right? Because the original place and the final place, so the final place is 3.9, the original place is 2.4, so whatever that is your delta D. All right. Tons of equation, lots of things to think about. Okay, it went from rest along with the electrical field. So in that case, is delta EE positive or delta EE negative? Okay, that's the first thing you need to consider. Okay, so going back to this picture, I am going from rest and I start accelerating this way with the electric field. The electric field is causing it to accelerate, so it should be a negative energy. Okay, so the first thing I can decide is I'm going to stick a negative in front of it. Okay, you got so many equations. Okay, I don't know if you want to kind of sum it all up from the pages. Okay, so I know that work is force times displacement, and I know that force is Q epsilon. Okay, and then I've also learned that delta EE could be negative or positive, so I'm not going to write all of them out. And then we've also talked about V is energy per charge. And we've also talked about delta V is equals to the change in total electrical energy over the charge. Okay, so these are all the equation. I know the other ones are just a variation of them. Okay, so let's go back. All right, so delta EE is negative, and the change in electric, meaning is work, is going to be the force times the displacement, right? And I know that delta EE is equals to negative because the FE, we learned that it's Q epsilon, right, with the force field. So Q epsilon times delta D. So finishing this up, they gave me my charge. They gave me my epsilon and the displacement. So negative 1.6 E exponent negative 19 times 250 times 1.5. So the answer I got is negative 6.0 times 10 to the negative 17 electrical energy. You can say joules or you can say Newton meters. Energy is energy, so I'm just going to leave it as joules. Okay, B, use the conservation of energy to calculate the speed of the proton. Okay, we assume the speed is 0. And we know that the change in the energy, the amount of change for the electrical potential energy, adding the amount of change of kinetic energy is 0. Are you okay with that? Okay, whatever that is lost from the electrical potential is going to be gained by the kinetic. And I know that I found that this is negative 6 times 10 to the negative 17. And I'm going to work out that the change in kinetic is going to be the change final minus the initial. EK1 equals to 0. EK1 is 0 because we said that it was started at rest. So this is 0. Okay. Bring the 6 over to the other side while I'm expanding. The EK is 1/2 mv2 square is going to equals to, I'm going to move this over and make it a positive, 6 times 10 to the negative 17. Okay, the only thing that I don't have is the mass of the proton. So hopefully at this point, you know that you can look up the mass of a protons. The answer is 1.67 times 10 to the negative 27. We have a constant in in our Google Classroom. Okay, there's a sheet of a picture. Okay, so 1/2 m27 v squared is what I'm looking for, is equals to 6 times 10 to the negative 17. So solve this. Negative 27, take the root. 6 to the negative 17 times 2 divided by 1.67 exp negative 27 equal, take the square root. So the final speed that I got, the acceleration through the field, is going to equals to 2.7 times 10 to the 5 meters per second. That's pretty fast, right? So that's why particle physics, you can create basically you can create element by going really fast, turning the kinetic energy, and you can go against the electrical field and get it really, really close to the center of the nucleus. That's basically particle science, how people create like extra protons and and neutrons in the nucleus, right? Okay, so keep going. Question 2. An electron leaves a negative plate of a cathode ray and travels towards the positive plate. The electron's potential difference between the plate is 1.5 times 10 to the 4. So let's draw a little picture here. So you got and electron, there's like a little hole. This is electron. It goes from the negative plate and going towards the positive plate. Okay, and the potential difference, so delta V is 1.5 times 10 to the 4. Okay, this is a parallel plate. Using conservation of energy and the definition of electrical potential difference, calculate the speed of the electron as it reached the positive plate in the cathode ray tube. Assume the electron initially was at rest. So V1 is 0. And they tell you the mass of the electron is 9.11 times 10 to the negative 31 kilogram. And the other thing that you need to assume is that you can also look up what is the charge of one electrons, okay? So it's 1.6 times 10 to the negative 19 coulombs, and it's negative. Okay, so going back, I need to know the conservation of energy. So the conservation of energy equation is change in electric potential adding the change in kinetic energy is equals to 0. Okay, so how do I find the electrical energy? So we go back to the definition. I have delta V given. Does it make sense that I would be using this equation? Okay, I need to find delta EE, and they gave me potential difference, and they gave me a charge. Well, they didn't give me, I know I can look up a charge for the electrons. Okay, so I'm going to rearrange this equation. So change in electrical energy is Q times delta V. Okay, so that's what I'm going to plug this. All right, so then coming back to this. So I know that it's Q delta V and 1/2 MV or EK2 final minus initial kinetic energy equals to 0. My only question is it plus or is it minus? Is it storing more energy or is it losing energy as this go? Okay, so think about it, right? Right now, this is negative and this is also negative. It's an electron. So if I hold it there versus say if I have it down here, when it's moving this way, am I storing more potential energy or am I losing more potential energy? Okay, the answer is losing. When I'm losing more kinetic energy, I stick a negative in front of this, right? So that's probably the only tricky thing to this type of question is you need to make sure you're careful with your plus and the minus, okay? So if that's a minus, and I'm just going to continue to do this, I know speed 1 is 0, so my EK1 is gone. I know the equation for EK2 is 1/2 MV2 squared. I'm going to move this guy over to the other side, so it becomes Q epsilon. Q times delta V. Okay, plug in what I know. 1/2 mass of the electron is 9.11 times 10 to the negative 31 times V2, which is what I'm looking for, and equals to Q times delta V, which is 1.5 times 10 to the 4. Sorry, squishy. All right, so pipe in the right-hand side first. 1.6 exponent negative 19 times 1.5 exponent 4 equal. Deal with that half, so times 2 divided by 9.11 exp negative 31 equal, taking the square root. So I got V2 equals to 7.3 times 10 to 2, 3, 4, 5, 6, 7 to the 7 meters per second. Okay, so that's the first one. Part B. Calculate the magnitude of the electric field, so I want epsilon, at a distance of 15 centimeters, which is at the end of the cathode ray tube. So when it gets to the end of the tube, I am looking for what is the distance. So we have the equation. I didn't write it out, but we have this equation for epsilon. It's delta V over D. So electric field is negative delta V over D, which is equal to negative 1.5 times 10 to the 4, all divided by 0.15. Sorry, are we okay? The distance is 15 centimeters, so 0.15 meters. So I got an answer of negative 1.0 times 10 to the 5. And the unit, epsilon, we said from yesterday is newtons per coulombs. But if you actually take a look at what other units could it be, it can also be voltage per meters, okay? So that's a possible unit that you can have for epsilon, or the electric field. Question 3. I'm going to stop. I need you to pause the video. Can you read the question carefully to yourself, and can you comprehend what it's asking you to do? An electron is fired horizontally at 2.5 meters per second between two parallel plates, 7.5 centimeters long as shown. So this thing right here is 7.5. So I'm going to change it to meters, so it's 0.075. The magnitude of the electric field is 130 newtons per coulombs. The plate is separate grain enough to allow the electrons to escape. Edge effect and gravitational are questionable. Find the velocity of the electron as it escapes between the plates. Alright, so I have the original velocity. I have the electric field equals to 130 newtons per coulombs. And I want to know what is the velocity when it leaves. Okay. If I tell you that this is very similar to a projectile motion, are you going to be so excited like I am? Yay! All right. There is an acceleration. Okay, just now, the first question that we were doing just now, we turned the picture around. So basically, what happened just now, the question 2, I'm going to draw a little bit of scribbling, I'll erase it afterwards. Just now we said that there is an electron that is sticking close here, and it's going to experience an acceleration going this way. Because at first it wasn't moving, and then if you go back to the question, we said that when it was 1.15 centimeters later, it is now traveling at 7.3 times 10 to the 7, right? So they're saying if this was 15 centimeters later, the speed here becomes 7 times 10 to the 10. Is it fair if I say that there is an acceleration happening along the y directions? Okay? At the same time, they're telling you that the object is also traveling to the right, and that's the x direction. So it actually becomes a projectile motion question. Is what happened is you are going to experience an acceleration that is going this way. And the acceleration is caused by what kind of force, if I ask you? What caused the acceleration? Okay, the acceleration is caused by the electrical force. Okay, so that is your F net equals to ma. All right, so let's see where this takes me. So I'm going to erase this picture. Okay, this is a projectile motion question. Meaning, if you understand projectile motion, we split it into x and y, and we assume that along the x direction, you would have a constant velocity, while along the y, you're going to have an acceleration. So meaning you're going to use your high five along the y, but then you're going to use the along x is constant velocity, so you're going to be using this equation, okay? All right, but that's only applied to the x directions, okay? So the velocity is going to go to, and they're asking you, what is the velocity? This velocity is summed up by the x velocity and the y velocity. The vx is constant, so this is your vx. Doesn't change, but what it changes is this v2. Okay, we need to find the v2 along the y direction. So I need to find what is the v2 here. But I also need a lot of different things, okay? Which type of projectile motion? I don't know if you remember, there's case 1, 2, and 3 projectile motion. This is a case 1 type because it's shooting horizontal. So what that means is v1 is 0 along the y direction. I need to figure out what is the acceleration by using these types of relationship, right? The force relationship along the y, okay? And what I do know is that the time it takes for the x and the time it takes for the y would be the same. Just like the projectile motion question, they are the same. All right, so let's work out what we can find along the y. Okay, so along the y and the x, so let's just fill in everything that I have. Okay, velocity, so in the question, they told you velocity x, right? So Vx is 2.5 times 10 to the 6 meters per second. They also told you that the width, meaning the displacement along the x, is 0.075 meters. Notice I can already find my delta t, right? So I'm just going to go ahead and I'm going to use the equation 2.5 times 10 to the 6 equals to dx, which is the 7.5 centimeters divided by the delta t. Solve for your t. So 0.075 divided by 2.5 to the exponent 6. So I got a value of 3 times 10 to the negative 8 seconds. So 3 times 10 to the negative 8 seconds. That's the time along the x. And we already said that that's the same time that I'm allowed to use for the y, because as it's moving forward, it's also moving up. All right, so I have that. And now let's find RA. Okay, let's find the acceleration. Okay, so acceleration equation that you know the most is F net equals to ma. So what is the F net in this case? We already talked about it. It is your force. So what equation do you use for the electrical force? I know since electrical force is equals to Q times the electric field, Q times the electric field is equals to ma. So Q is an electron. Electrons have a charge of 1.6 times 10 to the negative 19. The epsilon, they gave it to us, electric field is 130. Mass of an electron, also a constant, 9.11 times 10 to the negative 31, and there's my A. So punch it in the calculator and solve for what your A is. So I'm going to multiply things on the left-hand side first. So 1.6 exponent negative 19 times 130 divided by 9.11 exp negative 31. Okay, it equals to 2.28 times 10 to the 13 meters per second square. So I got the acceleration to be that big. Okay, so I'm going to fill it into here, 2.28 times 10 to the 13 meters per second. As you know, I like to store my answer in my calculator. Okay, so now that we've established all the givens along the y, I can now find my v2. So the equation that I'm going to use to find the v2 is from one of the high fives. So the first one, so v2 equals v1 plus a times delta t. I have everything that I need. So 0 adding 2.28 times 10 to the 13 times the time, which we found to be 3 times 10 to the negative 8 seconds. So 3e negative 8. All right, so v2 along the y is 6.8 times 10, 2, 3, 4, 5. Okay, I know that you guys are hating this because the numbers are so big. So I got 6.8 times 10 to the 5. So what does this mean again? Okay, I need to now find the overall velocity as it leaves. So I have Vx. So the velocity of the x doesn't change, right? So whatever it started with, it will be the same. And then now I found my Vy, V2y. So I finally now need to find my resultant displacement or velocity. I need to find the angle because it's the velocity. Okay, so Vx in this case was 2.5 times 10 to the 6. V2 I just found to be 6.8 times 10 to the 5 meters per second. If you need to, if you have a headache, you can pause the video and watch it again, okay? All right, so what is VR squared? This is a right angle triangle, so I'm going to use a Pythagorean theorem times 10 to the 6 to the square, adding 6.8 times 10 to the 5 square, all right? Adding 2.5 e6 square equal, take the root. So I found the velocity to be 2.6 times 10, 3, 4, 5, 6 to the 6 meters per second. And I need a direction. And so we're almost there. Tan of theta is 6.8 times 10 to the 5 divided by 2.5 times 10 to the 6. Angle theta is E5. 2.5 E6 tangent second tangent. So I got the angle to be 15 degrees. So direction forward 15 degrees up. All right, I know you want me to say we're done, but we're not. There's one more type of question that I wanted you to let you know. These types of questions, the other wording that they could be saying is find the vertical deflection. Vertical. What vertical deflection is if I have this plate and the electrons start here and you know how it goes like in a curve? The vertical deflection is from the original point. How far did it go? Okay, so basically if they ask for vertical deflection, they're asking for what is the delta D along the y. Okay, so that could be the twist to the question. But this question, the vertical deflection is actually easier. The final speed question, it's slightly more steps, but it's not anything you don't know. The only thing that's new to you is F net equals MA, but this F net is found by